Okay, welcome everyone. Today is our regular Sunday, and we're streaming from the terrace at Microsoft Office in Prague right now. Unfortunately, I don't think this stream will be lasting for a long because I see clouds behind me, and most probably it's gonna rain, and there is nothing on top of me, so I will need to pause my stream, and most probably it will be kicked out because of the network. So let's go straight away to solving our shit. So today's stream is gonna be purely natural stream, so I didn't prepare basically anything. Today I got, like, my friend linked me a top X asked questions in Google right now, and we're gonna solve it today. No system design, unfortunately, nothing, just going to solve them one by one as much as we can. And meanwhile, I'm gonna be looking on the chat, and that's basically the plan. So yeah, let's basically start. Let's start and go. So some of them I already solved because I was solving them for 2 days already. And let's just go with the next one. Let's go. Good. So yeah, pretty regular stream. You're gonna go with my pace pretty much. That's it. Nothing much to say. Good. Okay, so remove subfolder from the file system. This one is solved some time ago. Pretty recent one. Okay, I didn't know, but yeah, let's solve it again. Given list of folders, return the folders after removing all subfolders in those folders. May return the answer in any order. If folder I is located within another folder J. Oh, I remember. This is pretty... I mean, I didn't like this question much, so if folder I is located within another folder J, it is called a subfolder of it. A subfolder of folder J must start with folder J, followed by slash. For example, /a/b is a subfolder of /a, but /b is not a subfolder of /a/b/c. This makes sense, but in general, the problem description here is very confusing. I think this problem was daily problem once. That's why I remember it, and I was solving it quite some time ago. Why this problem is confusing? Because you know how the folder system works. So the format, I will explain you later, of a pass is one of more concatenated strings of the form / followed by one lowercase English. Okay, English letters, which is important thing. LeetCode and LeetCode problems are valid pass while an empty string are not. So we're not gonna get empty string. As I remember, this problem is for try data structure. So one key thing here, you may consider as a separate existing folders here only the folders that are in your input. So if, for example, you have /a/b/c and you have /a/b/d, it doesn't mean that you have separate folder /a because it's not in the list. It doesn't mean you have separate folder /a/b. This is what you need to understand. So for example, if this /a does not exist here, we're gonna be returning both of them. This is pretty stupid because when you know like how naturally folders work in file system, right? It doesn't make much sense. So for example, in this case, you can see that it is not removed. However, naturally, all of them are subfolders of A, right? Actually, all of these paths, they are subfolders of AB, right? Because it's gonna be ABC, ABCA, and ABD. So D, CA, and C are all subfolders of folder A/B, right? But as you can see in output, they are not separated. they are not removed because, yeah, if you don't have separate folder in your input, it means you cannot use it, right? So this is quite important thing. Hi, why are you decided to switch on Python? As I remember previously you worked with C#. I still working with C# on my main position here at Microsoft. Previously I was solving, so my LeetCode path was the following. So I started doing it with C#. I understood that C# is very cumbersome, like just simple array initialization is pretty hard for me. It's a lot of unnecessary symbols you need to type every single time. So I switched to JS. I was very happy with JS. To be honest, I didn't want to switch to Python, but then, yeah, I realized that some of the things are easier in Python than in JS, and then I completely switched to Python, I don't know, maybe 2 months before now. So yeah, Python now is GOAT. Like I would do LeetCode only with Python because this is the best thing. So get back to our problem. We are given this folder path, return the folders after removing all subfolders in those folders. So basically this is try problem. I mean this try data structure. What we're gonna do, we're gonna parse, as I remember, we're gonna parse the path here. Yeah, so we're gonna have, for example, in this specific case, we're gonna have our try, and it's gonna start with A, then A gonna have, or maybe I can draw actually. Come here, oh my god, where is my, yes, snipping tool. So we're gonna start with A, right? Then we have branching in our try to B. We have also C, and this is our slash kind of root. So yeah, we have root A, root C. C has D. D has E. C F, and C has F. Right, and we're gonna build this try data structure, and every single time when we reach the terminating folder, so the last folder, we're gonna check that, okay, this is kind of the folder that we might operate with. So with A, we're gonna put check because it's the single folder. AB, it's also a separate folder. CD, put check here. CF, put check here. And CDE, put check here, right? Good, and now what we can do, basically, folder AB is a folder of A, and CDE is inside a folder CD in your file system. So we're gonna return, in this case, A, CD, and CF. Right. So we basically going, we traverse a whole try, all the way down. Yeah, still not raining, good. We're gonna traverse all the try, all the way down, and we're gonna remember kind of the last complete subfolder that we visited. So for example, let's say we have some try pass, right? And we traverse in the try data structure one by one, and let's say this is the folder, this is the folder, and this is the folder, I don't know. Okay, maybe this is the folder. So since we want to remove only the subfolder, right? But what about the different case? If D has something, yeah. So in this case, we're gonna cut this thing here and remove and return only this. Let's also draw one more example. So in case of A, B, C, B, D. So our try data structure here will be the following one. So this is the root, A is subfolder, yes. ABC is subfolder and ABD is subfolder, right? So this is exactly our case. Yeah, and we're gonna have previously visited this one and both of them. So let's say we are following left path right now. We reached C, and for the C, the previously visited gonna be A. So this is how we understand that we should only return /A, right? And same will happen with ABD. Yes, ABD, and we go and we realize that this is only our pass, and we just add it. Okay. Yes, and this is how we return only this guy. And the last example, yeah, I can draw here. So the last example is A, B, C, A, B, C, A, and A, B, D. We have only these guys, root. So these are our guys, and previously visited is kind of last complete folder is not presented here, so this is what we're gonna remove. Return. So basically, yes, this is gonna be the algorithm, but I remember that there is another possible solution. So the algorithm will be the following. We built the try data structure. After that, we traverse this try, so following all the paths, and remembering the last kind of complete folder, and we just take the one before the last. So let's say in this case, of course, the last children will be the complete folder, because this is kind of how we're gonna build it. The last folder is always checked, so we don't care about it. We just take a look at the previous last visited, and it is this guy. And after that, we're just removing all this part from our path and adding this guy to some, let's say, hash set, in order to not have repetitions. And this is how it's done. But there is another approach to solve this problem. Basically, we can lexicographically sort the input, and you're gonna see what is going to happen, and this will help us a lot. So, and just then basically, based on prefix of current element, we can decide whether to include next one or not. And this is how it can be solved easily. So let me show you. Let's folder sort, and then print this array, and you're just gonna see how it works. Because yeah, this is how also the folder structure works. You can see that this is our sorted lexicographically array, and you can basically see that we can take this guy as a prefix, and whenever we see the same prefix, so we check this next element. It has this prefix? Yes, it does, so we don't include it. This guy has the same prefix /a? No, so we move forward, and now we're checking all the next elements with this prefix. So /c/d, is it the prefix of this guy? Yes, so we remove it. And /c/d, is it the prefix of this guy? No, because f and d are different, and this is our output. So this is one of the solutions. So basically, I don't know, results gonna be empty array. We're gonna traverse folder in folders. If let me go to Vim. So if it is empty, we're just gonna return current folder, and that's it. If it is not empty, we basically check. Starts with, is it the scene in the Python? I don't know. So we're gonna basically check last is going to be result last element if current folders starts with, I don't know, is it a scene? Let me ask GPT. Starts with for string in Python. Yeah, I still not that great in Python, you know. Starts with yes. Yes, nice. So, yeah, starts with this prefix, or last, let's name it as prefix. If it starts with, we just continue, or better, we can, if it does not start with, then we basically add in result append folder, and that's it. And next time we're gonna work with this folder, right? And then we return a result. Sorry, this is folder. Let me do it. Okay. Okay. Folder. Some naming. Folder fol. So let's just check it. So we're gonna work with what? Yeah, let's run through this example. Okay, this is our result. So first it's empty, we put in this guy. Then we moving forward, AB is. AB starts with prefix, yes it does. So we just skip, moving next one. Oh shit. Where did I go? Yes. CD starts no, we are pending, so /CD. Then CDE, we are skipping. CF, we are adding. Basically, it should work. Let's check this shit out. Oh, is this guy doesn't? So ABC, ABD. Ah, yeah, this is, yeah, since we might have different, why it doesn't work? Because in this specific case, it won't work, as first we're gonna add A, B, C, and then we are taking a look about A, B, C, A, and this guy is apparently prefix, as you can see, but it's not kind of prefix because C is complete folder, not CA. So I think maybe one of the solutions we can add here is to basically work, add the ending slash in the end. So yeah, and in the end, when we iterating, yeah, we can basically then rework with the output, and that's it. That's it, right? Yes. So we're adding folder, and when we working with this folder, we can do the following. So folder plus it's string, right? So it should work. Plus trailing slash starts with prefix plus trailing slash here. Yeah, this way, and yeah, but we're still adding without trailing slash. So yeah, slash is added only for during the computation. Network error, what the hell? Please no, it's at some point it happened to me. It means LeetCode is down or something like that. This is very bad, or is it me? No, it's not. Login, okay. This is pretty, I think, yeah, not very frequent event when the token expired for my LeetCode. So let's sign in again. Yeah, basically this should be a solution in this case, right? Yes. Oh shit, and now I think the raining is very possible. So yeah, it works. Nice, and another solution, maybe let's not go through it because it will be a bit cumbersome, is to build a try and perform this thing. I can actually show you what's gonna be the next solution. Yeah, complexity, we're moving through all the folders. So it's linear, basically, complexity gonna be linear. Is there a try? Yes, standard try Python solution. So exactly. So you can build a try. Insert file. Okay. Okay. So you built. Yeah, you inserted. What? Okay. So the logic is implemented here. So for insertion, we just go standard procedure for find. And what you're doing is find. What is this? Try find. Okay, so this is DFS, direct note, or whatever. Is end. Okay, some complicated thing. So I guess maybe I can show you from my submission. Oh my god. Yeah, this is the sorting solution, but I'm wondering what is the try solution. It's also sorting solution, sort folders, try. Okay, this is the try. Yeah, and you can see it's a bit more code. I don't want to code it completely. So it's try 27. Why 27? Okay, whatever. So remove, we create try. Okay, folder length, root. Then we move. Somehow he's working only with single character. However, in the folder name we can have strings, right? This is basically building a try and BFS. Yeah, so basically try is another solution, but it's a bit more cumbersome. I would actually not spend much time with this. So yeah, let's basically move on. So this is, we just did it, because to be honest, I'm very afraid of rain starting next minute, so I want to solve a bit more problems with you. But it's hard. Oh shit. Actually, hard ones I would skip for now, because yeah, rain will start earlier than we finish hard one, believe me. H index, I will solve it after it. So H index, given an array of integer citations where citations I is the number of citations a researcher received for their ith paper, return the researcher's H index. And H index is defined as maximum value of H such that a given researcher has published at least H papers that have each been cited at least H times. Okay. Okay, so it's his paper. Okay, what is it again? Maximum value of H so that the given researcher has published at least H papers. Okay. So for this citation, this is rating or whatever, citation number. Okay, number of citations per ith paper. So here he, for zeros paper, he got 3 citations. Here 0, for second 6, and so on. Okay, so here means researcher has 5 papers in total, and each of them had received 3, 0, 6, 1, and 5 citations respectively. Yes, since the researcher has 3 papers with at least 3 citations each, and the remaining 2 with no more than 3 citations each, their H index is 3. Wait a moment. I just a bit don't understand the description here. So there is 306, has 3 papers with at least 3 citations each. You mean 3, 6, and 5, right? Aha, okay. So basically, yeah, there are two dimensions. One is the number of papers, and another is number of citations. Okay, kinda understandable. So how are we gonna calculate this value? So for this, you can kind of calculate how much papers have how many papers have how many citations. So we see that only one paper got 0 citation, one paper got 1 citation, 0 papers got 2. No, actually it's at least this number. So one paper got 0. No, actually all papers got 0, right? Yeah, 0 or more. Then 4 papers got 1 or more. 3 papers got 3 or more. So yeah, let me brainstorm it. So there is 1 paper with 0 plus score. Oh, sorry, 2. Oh fuck, no. It's 5 0 plus, 4 papers with 1 plus score. Oh, sorry, citation. For some reason I name it score. And there is 3 papers with 3 plus score, 2 papers with 5 plus, and 1 paper with 6 plus. Can't we just sort this array and then basically go and let me try to sort it. So it's gonna be 0, 0, 1, 3, 5, 6. The rain will start soon. Okay, so these are gonna be our papers, and we know that the length here is 5. So we know that with this score we have 5. With score 1 we have basically 1 less, so 5 previous minus 1, 4. With this score we got 3, and with this score we got 2 and 1, right? So every single time it is decreased. And now after we build this thing, can we somehow define as maximum value h? So maximum, yes, such that the keen researcher has published at least h papers and cited at least h times. Yeah. So can we just after that go through all of this and just return minimum of 2 of these values? Will it work here? So for 113 it's gonna be what basically? It's gonna be 3, 2. No, actually no. Yes, so we have 3 with at least, yes, 3 here and only 1. Yes, seems to be actually working. At least H papers. Yeah, so we're gonna basically know how many papers for this specific number of citation. Yeah, let's basically try it. I don't know. So I don't know how to name it, this array. Maybe papers, I don't know. Papers is gonna be this one. And for the first, and also our lengths, let's just, so lengths, citations, or we can initialize it with 0. Right, then we go through all of them. And now, specific paper, papers, first one is gonna be length citations. We start actually with 1. And now for this specific paper, if the previous, yeah, also we're gonna sort it, right? So citations sort. I think by default in Python it's ascending, right? So now I guess what we can do is to check if papers is equals papers previous one, then current value is going to be papers I minus 1 minus 1. But if it's not, or it's equal, it's gonna be okay, if I don't like how it's coded up. So it's paper if they are not equal. If they are equal, otherwise it's gonna be just papers I minus 1. Or no, I think I have better idea. So by default it's papers I minus 1, but if papers, citations actually, if citations I is not equal to citations I minus 1, which is this case current, if they, yeah, then current minus 1. And then we just papers it's equals current. Then for each paper, let's call our answer, which is going to be, I don't know, 0 by default, whatever. Let's, hey, Microsoft recently came to my college for hiring interns and I applied, but I did not get shortlisted because of my GPA. What is GPA? Grade point average. Okay. I do have good projects, though. What do I do to target companies like this? I don't know, it's pretty hard right now for the market, so what you can do is just basically apply as much as possible for internship. It might be like, you know, even me, like if I start applying right now, I'll get a lot of rejections. However, I have a bachelor, master's, I have 7 years in commercial experience, 3 of them at Microsoft, hello, blah, blah, but I still will get a lot of rejections, that's okay. Binary search, yeah, it might be binary search. For now, I'm trying a bit different approach, but let's see whether it will work. So for paper in papers, let's try answer is minimum, no, answer is maximum from answer. No. Papers eyes, citations eyes. Let's just try this shit. might not work. Actually, yeah, you see I solved this question, but I completely forgot how did I solve it, to be honest. So for now it's kind of pretty unknown for me. Let's try why it doesn't work. Maybe I fucked something up, right? 1, 1, 3, 3, 2. What is 2? Wait, papers, why it's 2? Aha, yeah. It won't work this way. So for this case, 1, 1, 3, what can we do? Maybe we can do something like this. So, papers count, then citations, right? And what we can do, yeah, we can do this one. By default, this is our papers count, and then it's going to be papers count minus equals 1. And here, let's check whether it's gonna work. So we have 4 at this point. Yeah, it's not equal. We put it decrease. Yeah, for this case should work. For this case, 3. Yeah, let's try. Work, but I'm not sure whether it's good approach or not. Yeah, it works somehow. I have no idea how, because yeah, but binary search might be actually one of the solutions. Let's check. To be honest, guys, I solved this question when? April. I don't even remember what was my solution back then, what it was. Buckets, some buckets, some count. Oh yeah, it was on JS. So in April I was still using JS, right, not Python. Interesting. So what is the topic? Sorting, counting, sort. Yeah, so sorting was a good call actually. This approach to sort the array first. Nice. And then what are possible values of H index? Fastest approach is to use extra space. Yes. Yes, so what is the solution? Bucket sort. Okay, always throw me off. Okay, so they go through all the citations, and there is, oh my god, there is some bug. Want to get into my laptop? Fuck off, stupid shit. Okay, so yeah, they go this bucket sort. They go through citations. If citation is more than n, makes sense, then buckets n. Sorry, I don't understand this for now. I don't understand this. So sort, enumerate n minus I. I think this is pretty much similar what we did. Okay, let's try to understand bucket sort. So what this guy did actually is, okay, the idea behind some bucket sort mechanisms. First, you may ask why bucket sort. I have no idea what is bucket sort, by the way. While the h index is defined as a number of papers with reference greater than a number, assume n is the total number of papers, n plus 1 buckets, number from 0 to n, then for any paper with a index of the bucket, we increment this count by budget. Okay, exception is that for any paper a large number of reference, we put it in the n's bucket. Ah, yeah, because n's is the maximum. Okay. So let's basically try to go through this thing. This is usually how you should solve the problem. Even if you solved it, you should go and check all the solutions and then try to understand them, because yeah, the point of LeetCode is not to just solve the question no matter what. The point of LeetCode is to solve it the right way and know what are the other ways, what are the other patterns that you can use to solve the problem, because they might be used in the next problem. So okay, we have some buckets, whatever. Let's try with this guy maybe. Yes. So we have buckets. 0, 1, 2, 3, 4. These are our indices. This is the buckets. So by default, I think it is C++. Yes, seems like that. And we have zeros everywhere. And we're iterating over citations. And for 3, for example, if 3 is more than n in our case is going to be 5. 3 is more than n, no. Then for this bucket, it's n plus 1. So let's do one more. So for this bucket 3, we are incrementing, so 1. Then next one, 0. For 0, we increment also 1. For 6 is more than n in this case, so we increment in the last one. Right? Yeah, n. So this one is 1. For 1, we increment also 1. And 5, we increment 2. Okay, right now, and this is counting sort. Okay, kind of makes sense. And then we have count as a variable equals 0. We're going through the buckets. And we increment count with the index. Okay, so let's. So we have. We're starting from the behind. So this is our index. We're adding 2 to count. Is 2 more than I? So index is 2 more than 5? Yeah, because 5 in this case is the number of the papers. So it's not. In this case, we just skip it. Then we go here. Is 0? So count 2 more than I. 4 in this case. No, 2 is not more than 4. We move here. Sorry, we should add also. Shit. So we add 2. Then count more than 5, no. We add 0, nothing changed. So we add 1, this becomes 3, and it's, yes, and in this case we return 3. Okay, kind of makes sense. Let's also try with this example. I don't know how come and what is my actually solution. How did I come up with it? Somehow, I don't know even how. So 3 is gonna be 3, 1, 3, 1, right? Bucket sort approach is not intuitive if you already don't know. Yes. It's not intuitive, to be honest. Yeah, I mean, this thing is this part kind of intuitive. This one is not much yet. So let's try. In this case, what's gonna happen? What is going to happen here? Okay, so we are going through these buckets. Whatever, we have 0, 0, 0, 0. Okay, so 1. We add 1. We have 3. Add 1. 1, add 1. So gonna be 2. Now starting from this count is 0. adding 1. So 1 more than 3, no. Moving here, 1 more than 2, no. Adding here 3. Right, 1 plus 2 equals 3, and 3 is more than 1. Yes, so we return 1. Yeah, not very intuitive, I would say, but somehow we solved it even without it. Let's put here done as well. Good. Symmetric tree. Let's go. Given a root of binary tree, check whether it is a mirror of itself. Yeah, apparently I solved it as well some time ago, but I don't really remember the solution as well, so let's think about it. Okay, we have this tree. 2, 2, 3. So we should check the values. Okay, so for this guy, we are checking left and right. And then for left and right, this compares with this, and then we comparing left, right with right. Shouldn't be something like this, like definition, compare, we have left, yeah, let's say left and right, then if not left or not right, straight away return false. Then we compare if left value not equal right value, we return false as well, because symmetric trees should have same values, right? And then hey man, you seem cool. Thank you. Do you do this live daily? No, I'm doing it weekly for now, so every Sunday or Saturday evenings we are performing LeetCode and system design. So yeah, please subscribe. The most important part, guys, is to subscribe to my Telegram, because all the updates, news, insights about my life and corpo stuff, Microsoft, it's going to be here, so I just wrote it. Yeah, this is my Telegram, you can just find it, or find me on Instagram as well. I'm posting the streams announcements there, so you're not gonna miss it. Then what we're gonna check is if not compare. So what we want to check with left and right, that we want to check, so left these three and right are the same, or not compare left right and right left, or we can just return it. So this guy and this guy should be true. Like that. And then we just return compare root left and root right. And what are constraints? Will we always have root? Yes. Let's run it. Oh shit. Okay, why it doesn't work? Okay, if both of them are not left and not right, return true. Subdan, I'm also doing DSA for Fang. Do you have Twitter or something you would love to connect? Yeah, sure, let's do. I don't know how to connect. I'm mostly on Telegram, to be honest. So just, yeah, write a comment under any post and I will find you, no problem. I will chat to you, like, write to you directly. So, sorry, Twitter I think I don't have, unfortunately or fortunately. Yeah, good, this thing works now. And follow-up for us is to do it also recursively and iteratively. So in this case, my gut feeling that just emulating stack is going to be enough to have it iteratively. So let's have our stack here, then stack push. By emulating stack, we're just gonna use, instead of recursive function and its input parameters, we're just gonna store on our stack our input parameters themselves. So here we just do root left, root right as a first thing for the stack, and then while len stack more than 0. And basically what you should do is generally to copy paste, and then you're gonna kinda see. So our input parameters, they don't exist yet, so let's have them. So left, right is going to be stack pop. And now all of these this we just skip, because we don't want to return after we just got to some random leaf, right? This is true. And then what we are doing, we are putting a stack append and these two guys, then stack append these two guys, sorry, tuple. Yes, and if everything was all right, we return true in this case. Should work. This is how we transform recursive to iterative. Ah, shit. Stack pool, what? This object has no attribute pool. Oh, yeah, it's from JS. I'm sorry, it's from JS. From JS, sorry. Yeah, JavaScript leaves some return false. What the hell? Okay. I'm sorry, we still need to check if not left and not right. Then we kind of skip it, continue. Yes. You cannot just remove the code from it, right? So this is going to be our iterative approach. Time complexity and space complexity is exactly the same, because recursive calls, they are kind of part of memory. So in this case, our memory is the depth of our tree, which depends on the input, right? But in balanced tree, it's going to be log of n, and time complexity is of n, because we traverse every single node. So this guy basically is done as well. Sub done. Yeah, thank you. Okay, cool. I will leave a comment. Yeah, sure. Go for it. I will reach out to you. No problem. So this is gonna be done. Majority element. Oh, I think I know this. Sorry, I just know it. This is top something Google asked questions. But this question I already know. I know it. No, I don't know it. I just recalled it and thought it's maybe some this majority voting algorithm by some guy. Now let's see, majority element 2. So given an integer array of size n, find all elements that appear more than n divided by 3 times. Okay. So yeah, with this majority voting thing, it will work if you have majority that is n divided by 2 plus 1, or just n divided by 2, then it will work. But this we have n divided by 3, which is a bit more complex in this case. So still, this shit is still not running, but oh, what the hell, this is dark and very sad vibe, you know, dark vibe. Whatever. So num to 3, it's 3, 1. Sorry. Find all elements that appear more than n divided by 3. I mean, yeah, voting algo, but voting algo, it works with the majority, but so it works with this constraint. let's think through it. So first thing, like in any interview, try to solve it at least somehow, and then you can improve. So in this case, we know this number, right? So more than n divided by 3. So we can define our threshold by something like this, and it should be more. Right, so we should just count all unique numbers. Yeah, so easy approach, sorry, kind of brute force here would be that we can just put it into the map, count the number of times we see this number, then go through the map, check if the number of frequency is more than this threshold, and then put it to a result. But there is follow-up later on. Let's check it later. I think the follow-up includes this adjusting the voting algorithm that Ritik is talking about. So so let's create some map. Hash set, I don't know, in nums, if num not in hash set, then hash set num equals 0, then hash set num, or I think we might just use counter or default dict, whatever. I'm not Python guy, so sorry. Yeah, you're gonna see this type of shit instead of counter and default dict, fancy stuff. And now, yeah, what we can do is to traverse this hash set, and whenever if hash set key more than threshold, we're gonna just return it to our, or sorry, append it to our result. Yes, something like that should work. What? Type. Yeah, works. This is O1, right? But we have follow-up. Another brute force would be sorted and return middle element. No, because you need to. No, check this out. It's a bit. I think what you're talking about is majority element, just regular majority element. This guy includes voting algorithm that you're talking about, but here we have constraint n divided by 2, and this is only a single constraint that appears here. It also has this follow-up, and follow-up is using this fancy algorithm, and I think I solved it with this algo as well. Yeah. So basically this is algo you're talking about with constant space. But in that case, where is this shit? Yeah, in that case, find all elements, so it's not just single element. So sorting with middle element won't work here. Could you solve the problem in linear time, and also we should solve it in linear time. So constant space. I mean, for linear time, I don't know. This voting algorithm won't work here, right? I don't know. We should somehow adjust the voting algo. Yeah, but this voting algorithm, it won't work here, because you see we just have some count and current element. And in the end, the element, after canceling out everything, it's going to be the right element. But n divided by 3, so this algo won't work here for sure. Okay, and sorting will not give us linear time, unfortunately. With sorting, it might be possible to handle with constant space. All right. Maybe we can somehow. What are constraints? No, constraints doesn't seem like helping here. Okay, let's check hints. think about the possible number of elements that can appear more than possible number of elements. Aha, because numbers are repetitive. Okay, what do you mean? Can it be at most 2 and why? Ah, okay, this is quite interesting. So, 1. So let's think about this. Let's say let's sorry. Let's basically think about some examples here. Yeah, I think this makes sense. So we should return all the numbers that appear more than this thing, right? And how many such parts we have? We have only 3 such parts, right? And this is a very good hint. I would still say we might return 3 numbers at most. Because we might have this situation, 2, 3, 3, 3. In this case, we should return 1, 2, 3, no? Let's actually check. Let's actually check this. So, example, if we have this guy, what should be returned? What will they expect? Aha, okay. This is, yeah, it should be strictly more. I'm sorry. So it should be strictly more. So our number should be strictly more than n divided by 3, which means one guy should be less than n divided by 3, and we have only these 2 numbers, right? Which is kinda interesting information by what it gives to us. So if we have just one more 3, if we have 3, we're gonna return only 1 element, right? And in this case, we're gonna return 2 elements. Okay. It can be only 2 elements, right? Do hard question. Man, I mean, I have only 30 minutes more and it can start raining every single possible time, so yeah, next stream, if you want, we're gonna have some hard questions, but I'm not that good. I don't want to be stuck for like 1 hour, right? Which is quite possible. I'm not that good at LeetCode. I'm just preparing and getting back my skill. Okay, so we might have only 2 numbers. Yes. Let's check third hint. Consider using Boyer-Moore voting algorithm, which is efficient for finding elements that appear more than a certain threshold. Maybe we can kind of split this array in 2 and then perform voting algorithm. And that's it? No, can't we? This guy has how many? 3, 4, 10 elements, right? So by 5. If we split this guy here and perform voting algorithm, we might clearly see this guy gonna win 1 and this guy gonna win 3. But it will not be correct. Yes, so this Boyer, how it's called, Boyer-Moore or Moore voting algorithm should be used here, right? But how? Efficient for finding elements that appear more than a certain threshold. Is it for certain threshold? I thought it's only like you kind of know that it's majority and that's how. Gosh. Yeah, this guy we need. Majority of sequence elements is in linear time and constant number. So it just needs to find majority, right? I think we can divide into two, but what it gives us, this is, I don't understand still. Let's drive some easier examples. So 1, 2, 3. If we divide it like that, we shouldn't return anything here, right? So how we can majority element, let's say it will return us 2 and this guy return us 1. So we have 2 and 1 or 1 and 3. But in this case we should not return anything. And can't we just then count how many results we have? So let's even say this is our algo, right? We split array by 2. First will give us 1, second will give us 3. And in that case, then we move through an array and we know that there is only 3 ones and 4 threes. And we know still the threshold. Yeah. Oh my god, yes. I guess I got it. So we will, yes. So the algo, we split array, we run a voting algorithm on both halves, and then we check for 2 results whether they are strictly more than threshold. There is one still problem. I just want to drive this example. If we split here, it might be a bad split. What if this is the case? We clearly need to return 3 and 2 here, right? Or even worse, what if this will be the case? Yeah, this is the problem. Yeah, like dividing doesn't really work here. Maybe then we might split it somehow differently, like here, for example. And then this guy will clearly win. Yeah, maybe we can split not in the middle, but on the third. So how many items here? 9. Oh my god, let's have 8. So 8 divided by 3, it's 2. So let's say we split in here, and in that case, like let's say it's gonna be 3 or 2, doesn't matter, and then we split here, and it will be clearly 2, but not 3. Yeah. I think that's it. So let's at least try. If it does not work, I will just take a look into the solution because it takes us a lot of time. So voting, we have some start and end index inclusive, and count number none, count 0. We go for E in range start and +1. We are doing if nums I equals let's say if not num, sorry, if num equals none, then num is or let's not do this fucking bullshit. Let's maybe do this num start and start, yes. If num equals nums i's, then we just increase count, else we decrease count. Think if count equals 0, num equals nums i's. This is the algo. What if we split in 3 parts? Might be possible, I don't know. Let's say here we split 8 divided by 3 is 2, right? 2, 2, and 2. So this will give us 2, this will give us 3, this will give us 2, and this will give us 1 or 2. Yeah, actually splitting in 3 parts might be a very good idea. But let's first run the example. So we have this guy, we have threshold, and now what we should do, candidates equals how to properly run it. Okay, number 1 is equal to voting from 0 plus and threshold, right? 0 to threshold, and num2 equals voting from threshold plus 1 to threshold times 2. Since it's inclusive, right? Or maybe we can do different. Oh my god, why I'm doing this stupid. So length nums minus threshold, exactly, maybe minus 1. Oh shit, it's hard. Let's say we have 5. 5 divided by 3 is 1. Let's say we have 1, 2, 3, 4, 5. Len is equal to 5. Threshold equal 1. 5 minus 1 is going to be 4. 0, 1, 2, 3, 4. Yes, we should do minus 1 here. And then num3 equal voting threshold plus 1 to this guy. I guess something like that. And then we just do for num in nums let's just check whether it works. Yeah. Oh my god. I don't know, like, how to organize the code better. I don't like this thing. Oh my god. Why do I do this stupid shit? Count +1, and after this guy, if count more than threshold, unsuppend threshold. And our answer is gonna be this guy. Alright. Right. Let's try to run. Most probably it will not run from the first try, but let's just check. Threshold is not defined. What do you mean it's not defined? Boundaries might not be the good ones. The threshold might be can I just slice this array? It will be much fucking easier. So yeah, I would just put it array from array 0. I don't want it, sorry. So from 1 to len array, this is it. And then I would do just the following. So array from 0 to threshold +1, if len array equals 0, we just return -1, some random number, whatever. Yeah, so this should be it. And how can I split array in Python? Oh my god. How can I split array in Python? Okay, whatever. I will do it different way. You know what? So, first chunk is going to be yes. So first chunk is going to be this one, while len first chunk less than threshold, first chunk append nums pop. Yeah, we're gonna go from behind. And this is how we basically voting first chunk, then we perform again the same thing. Yeah, sorry, this is very bad code, but I mean I don't have time. So yeah, and nums pop. But what for this case? What about this case? 1 and 2, it should return 1 and 2. 2 divided by 3, it's gonna be 0. Okay, fuck it, I don't know. I don't have much time for that, so let's just where more majority vote and my elaboration. Okay, so what did you come up with? Count 1, count 2, candidate 1, candidate 2. Ah, oh my god, this is much simpler. We don't need to split anything, it's a bad idea. It's a very bad idea. So basically, no, what we should have done in the first place is to have just two numbers, since we're gonna have only two numbers max. So num1 and num2 equals, I don't know, nums. They might be don't want to count the same ones, right? What if it will be 3, 3, 2, 1? Okay, so num1, let's start with none. Num2 equals none as well. So for num in nums, if num1 equals none, we just assign. If num2, if num1 equals num, and count equals 0, num2 count equals 0, then num1 count plus equals 1. Yeah, and then if num2 equals none, I think we should not mess up the ordering here. Num2 equals num continue, same thing here. If num2 equals num2 count plus equals 1, then if num1 should have somehow else if be initializing, this one's gonna be num1 equals num count plus okay, here we want to do else and maybe put this guy inside. Yes, I think this one how I will do it. If at least one of them equal, then here we check if num1 equals num, then num1 c else num2 c equals 1, else in case no one is equal, then what do we subtract from? Should we subtract from both or from one? Yeah, I want to keep them different, and then num2 plus, okay. Else, let's try to subtract from both of them. So num1, 1, num2 count minus equals 1, and if num1 count equals 0, then... Ah, shit. Okay, I'm stupid enough for this. I'm sorry, I can't figure out. So, here the case. So candidate 0 and 1. Somehow candidate 1 and candidate 2 is 0 and 1. I have no idea why, but whatever. We iterate through all of them if n equals candidate 1 count, okay. If candidate 2, okay. If 0, okay. If this 0, okay. Beautiful naming, I don't know. Okay, potential majority NML candidate, okay. If count 1 is 0 and current number is not equal to candidate 2, okay. If count 0 and num's not candidate, okay. Okay, adding the counts, removing both of them. This is kind of what we are doing, no? This is what kind of we are doing. Let's maybe initialize these guys. Okay, so just one thing that we should change here is the following. This is gonna be elif, and this one gonna be if num, yes. So if num 1c equals 0 and num is not equal to num2, num1 equals num and num1c equals 1. If num2 count equals 0 and num not equal num1, because we don't want them the same, num2 equals num2c equals 1. Else if any of them equals, yeah, we increase this and then decrease it. And the only thing that we should check later, if num1, okay, it is, okay, this is rain. Let's finish it quickly and I'm finishing stream. Threshold as num1, if num2 threshold as append num2, then as equals this guy. Okay, yeah, we finish in stream. Sorry, it is raining. Personal hotspot. Shit, threshold. and nums divided by 3. Speed up. It's not fucking working. Yes, nums count this guy and nums count this guy. Beautiful. And yeah, so it was apparently the oh my god. Please don't do this to me. Yes. Okay, we solved it. Nice. With counting algorithm, 0 extra space, guys. So we did it with Boyer-Moore algorithm. So now I just gonna switch to my personal hotspot. And if